solve practical problems by bringing new products to market, changing building codes, or developing new therapies. Their work takes an interesting approach to design, test, and redesign products using a set of simulators where ideas can be safely evaluated in a repeatable way in conditions ranging from a cold, snowy winter day to cramped home bathrooms to a patient room in a hospital. Tillich completed his PhD in mechanical engineering in 2012 at the University of Toronto, focused on preventing back injuries in caregivers. He is listed as an inventor on a number of patents, including one for the design of a pneumatic patient lifting device. His past work includes studies of scooter maneuverability to make recommendations for changes to building codes, as well as the design of anti-collision systems for power wheelchairs. Tillich's current work includes the development of measurement tools that allow for measuring activities outside or in people's homes rather than in the laboratory. So I welcome Dr. Dutta, and I'm really excited about this lecture, so let's get started.
Okay, thank you very much, Laura. I'm from Toronto Rehab Institute, and I was going to just jump in, but maybe I should just pause and take get a sense of what your concerns are. I know we just chatted about how, preventing falls and keeping moving and trying to get away from a walker is something that you're interested in. What are there other things that people have, targets or things that they're, life goals that you're trying to things that as you age, you're thinking about and trying to prevent? Yes?
Walking outside during the winter when there's icy and snow and sidewalks, especially since I live downtown, it's so busy everywhere.
Yes.
And you are afraid to slide, and especially on the crosswalk where there's no sign.
Yes.
I like the stop signs.
Yes.
And
yes.
over the last few years.
Okay.
It's become a bit scary. Footwear to go with that, I guess. But
excellent. We're going to talk a lot about footwear and ice and snow and what we're doing about that. Anybody else? No? Okay. Yes?
Arthritis.
Arthritis.
Things.
Okay.
What are the tools for those?
Okay. That's a good one. We don't look at that directly in our team, but I'll think of, while we're going here, I'll see if I can think of something to address that issue. Okay. Let's start with a video. So this is getting at the falling risk and winter conditions. Watch in this red circle area. I know it's not terribly clear. So watch these people as they try to cross here. Did you see that?
Yeah, I've done it.
You've done it? So I'll play that again, just so you get a good sense of what was happening there. This is at University and Elm Street, near University and Dundas. So Sick Kids is just sort of up in the corner over here. This is where our lab is, at this corner here at Toronto Rehab Institute. So we have a camera up on the 12th floor looking down on this intersection, and we record some interesting things in the winter. How's my volume? Can everyone hear me fine? Yeah. Okay, so we'll watch this one more time. There's the fall. So why did that fall happen? What are the possible reasons that person might have fallen and slipped there? So slippery. So it's maybe the ice and snow. So weather.
The deep snow.
So there's deep snow there. Yeah, the snow wasn't cleared properly. There's someone's balance problem. Yeah.
Could have been hurrying because there was a car turning.
Yes.
This is a double crosswalk.
Yes.
People tend to want to really get across in one, and it tells you not to.
That's right. Good. So rushing, maybe. Yeah, definitely. Watch, in fact, what happens. Oh no, I don't think it's on this video. Sorry. So those are all good. Okay, so it could be. So I think you've hit on all of the major things. The only other one that might be is that it's sort of linked to the balance issue. As we get older, the receptors on the bottoms of our feet get less sensitive, and so you aren't as aware of your postural stability, and you have a greater chance of falling over. We're going to talk about, so there's really 4 things that might have caused that accident, and we'll talk about how we're going to try to change all of those things, okay? What about walkers? What do you see what do you think of when you see a tool like this being used in the snow? It doesn't look terribly useful here, does it?
It's no good.
It's no good. It doesn't work, right? Snow, ice, as soon as there's any snow on the ground, things like walkers, canes, any wheelchairs, scooters, none of them really work very well, right? That's one of the things that our lab is trying to figure out how to make better tools to get around in these sorts of conditions. Again, wheelchairs, this deep snow again, the issue here. Part of the, when we talk about the snow was too deep, why was the snow too deep at that intersection? That's a question that we're wondering.
They scrape it for the cars.
They scrape the area where the cars are going, right? So the road ends up being really clear where the cars are driving, but where people try to cross the intersection, where there's that curb cut, right? So you have that sloping ramp that gets covered in ice and snow, and it's packed full of slush and slippery stuff, right? And so you're on this icy ramp for a good part of the time when you're walking around. And that's where all the snow tends to accumulate, making it really hard for anyone using an assistive device to get around. So these are all problems that we want to address because we know that people stop going outside often in the winter, right? Seniors will have told us that, as soon as there's snow on the ground, people just stop going outside. And it makes sense because you're worried about falling and hurting yourself. You're worried about the consequences of a fall. They are very serious, right? A hip fracture, if you happen to fall and break a hip, that will change the course of your life. Half of the people that have a hip fracture will die as a result of that in the year that follows. So it's a very serious problem. But it's equally as serious that people stop being active, right? Because our bodies start to degenerate and become less healthy if we don't stay active, if we don't get out to the grocery store and to the doctor's appointments and get your exercise and go for your walk. So we're trying to balance these two things, right? We're trying to keep people active in the winter, but we also need to prevent falls. So that's what we're always trying to do in the work that we're doing. We're trying to figure out ways of addressing those things. This is a simple little product that we came up with to address one of the balance issues. So we're talking about the sensors in the bottoms of our feet, in the soles of our feet. It's when they wear out, what you can do is simply add a ridge around the outside of this insole that will dig a little bit deeper into your skin, and it will provide more feedback. And we've done some studies on this that have shown that people who are at risk of fall, so fallers, people that have fallen in the past year a few times, we can cut their risk of falling by half by simply wearing these insoles. So it's an example of a really simple idea, but it works really well.
Where would you get them?
So I can give you information. I have some cards here. You can write down my email address and send me the information. We'll get them. We'll make sure you get in touch with the people that market these.
Can I just comment that
Of course.
does not go in the shoe if you have an orthotic? I have.
That's a good point. Yes. So that is a limitation.
How do I adapt that to my orthotic?
That's a good question. We don't have a solution for you yet,
Okay.
but that's an important piece of feedback. Let me write that one down. Yeah. That is, I have a pen. I don't think I have a pen. Do you have a pen I could borrow, Laura? Chance? I don't know if I brought one with me over here. Actually, I have one. That's right. Yeah. Other questions before I keep going? By the way, we can do this as I'd prefer to do this as a sort of continuous conversation as we go here. Sole sensor. Orthotic.
Are these special soles, are they individualized, so you have to go in there?
They're sizes. You don't have to go in. There's just different sizes, and you buy the size. Yeah, you just slip it in, and there's nothing else you have to do. Yeah, they're not really individualized. So this is getting back to the issue with the curb cut, right? Even when the snow is melted and it's warmed up, you still you see it, the roadway is all clear and the sidewalks are mostly clear, but the one spot where we end up with a ton of water is right where you want to cross, and you end up with that pile of slush right where you want to cross, right? So we actually think that the design of intersections is wrong for Canada. This design with curb cuts, we always talk about being accessible. The curb cuts are designed to allow wheelchairs to get on and off of curbs, but we actually think it doesn't work that well where we live. So this is what we propose to do, and we're working with a councillor, Josh Matlow, with the city here, to try and do a test intersection where instead of the sidewalk dropping down to meet the road, we raise the center of the intersection up so that someone crossing here doesn't see any change in height, but cars driving along the road would go up a very slight ramp. It's exaggerated here quite a bit, but you can imagine the car would have to go up this slight rise as they approach the intersection, and the pedestrians and anyone else can cross on the level in both directions. So we think this is a really interesting idea because you get a number of benefits. First of all, you don't have to go up and down for pedestrians. Secondly, water and snow and ice and stuff drains away from the intersection, so you can have your sewer catch basins outside of that area. You also now get the ability for a plow, when they're plowing the street, to cut across this whole portion of the road and the sidewalk, right? You can just scrape that whole area clear of snow and ice. So that, we think it has a lot of promise, and we'd like to test it out. So keep your fingers crossed. We're fighting hard with the city to try that out. So footwear was another person suggested it was a poor choice of footwear. So here's two pieces of footwear. What do which one do you think would work better? The one on the right. You're wrong. So I'll show you why. We flip these shoes. Whenever we buy shoes and boots, we always turn them over and look at the soles, and they say, "Oh wow, look at the knobby teeth on this one, right? It's going to work really well." But unfortunately, it's all cosmetic. People make boots to look good, so that people look at them and say, "Oh yeah, that looks really grippy." But unfortunately, they don't always work. And I'll show you some of the testing we do with these shoes, and you can see you'll see the difference right away. We do this sort of testing, we talked about simulators. We have a simulator for winter because we need a safe place to be able to do testing like this where we won't hurt people. So we actually have this little pod. It's about 6 meters by 6 meters, and we can create ice and snow inside there and drop the temperature down to -12. And we can put it on what we call a motion platform. So this whole thing gets lifted up and placed on top of this motion platform, and this thing here can change its angles, and it can move up and down and side to side, and we can create icy slopes. So I'll show you a video of what that looks like. Let's see. So in this case, I'll just give you the background here. So this is the inside now of that pod that we were looking at, right? So we've got an icy floor sort of in this area. We've got a pile of snow over here that we created. We have a box that sort of makes snow, and we bring it in here when we need it. And we have this icy walkway here. We're testing out a few other materials. This is a concrete surface, and this is the tactile surface you get on the subway, on the edge of the subway platform, to see how that does when you have snow and ice on it. In this case, we have our participant walking back and forth on the ice surface, and what we're going to do is tilt that pod to different angles and see when that footwear starts to slip, to really tell how well it works. So if I play this again, and this is boot 1. I won't tell you which one boot 1 is and boot 2 is from the two that we saw on the screen earlier, but I think you'll be able to guess soon. So here's on level, and now we've tilted to 5 degrees. Okay, so these boots do okay at 5 degrees. Now here we go to 7 degrees. Let's see how that does. So now you can tell you can't even start the walk at 7 degrees. Right? So those boots didn't work very well. They got to about 7 degrees. By the way, you'll see the thing that's harnessed, the participant here is harnessed to an overhead robot, essentially. It's this thing that follows you along as you walk around, so that if you were to ever fall, it would catch you. So you'd never hurt yourself. You'll see in a minute here a few little falls. Okay, so that was the first boot, and that's on dry ice. We can do wet ice, we can do snow-covered ice, and you'll see some of those things in a second. Here's boot 2 at 0 degrees, does fine. Here's at 10 degrees. So already we beat the other one. Here's 13 degrees. Here's 15 degrees. This is quite a steep slope, so it's it gets hard to actually climb this hill sometimes. And I think in this case the boots didn't actually fail. It was more that our participant lost a little bit of balance there. So, but in any case, we get somewhere around 15 degrees at least with those other boots on dry ice. We can do, like I said, we can do the same thing with wet ice. So we actually take a mop and soak the surface of the ice so we get a nice slick wet surface. And do the same thing again. So this is boot 1 again. So there's 1 degree and you can see him slipping and sliding around already. So barely, barely any incline there at all. And here's 2 degrees. And he almost can't even make it across and slides backwards. So that's boot 1. So wet ice, so water on top of ice made this one perform even worse, right? It was 7 degrees, I think, in the dry, and now it was here. Now we go to, oh, this is just a picture of the snowmaker. Here, sorry, let me just go back. I think I've lost track of where we are. I'll show you boot 2. Which one's boot 2? Here's boot 2. No, that's dry ice. Oh, I hope I didn't goof up the... Here, I'll just figure out where we are here. 1, 2, 3, 4. Oh, I might be missing boot 2. Yeah, I apologize. I think I'm missing one of the videos here. Let's see if I can... I think I have it on the desktop. We'll talk about toilets later, as you can tell. So boot 2 wet.
Now, the boot 2 is the one with the...
with no sole, basically.
No sole.
Yeah, no sole. It's just a flat piece of material. So there's 5 degrees on wet ice. Remember, boot 1 failed at 2 degrees. Here's 10 degrees. So that's doing better than boot 1 did in dry conditions. Here's 19 degrees. And here's 20 degrees. This is the highest our lab can go. We can't go any steeper than that. So that exceeded the angle that we could.
What is that sole made of?
It's a material. So we're working with Marksburg Warehouse to develop new materials, and this is a new material that they're testing out. So they haven't even, they came up with the material and they're trying to see how good it is, and so eventually they will put a tread on that. But it just shows you how amazing, basically all winter footwear should start to approach this, right? If there's a standardized way for testing shoes and boots, and footwear companies all test the same way, and they label their shoes based on that sort of information, that's our dream, right? Is to be able to provide this sort of information to people. On the label, you would see this can make up a 20-degree slope, no problem on ice. We think that everyone would start using these sorts of materials for their footwear, right? Yeah.
Why would they put a tread if it works flat?
So let me show you.
And also, how
Yeah.
do you do on slopes that go like this that are icy? It does just as well?
Going downhill, you mean? Or you mean side, like cross slope? Do you mean?
No, if you're walking down an icy slope like that.
Yeah, walking downhill. So here we.
It does well.
Yeah, it does. I mean, when you're walking downhill on a steep slope, the challenge becomes balancing your body weight. Like it just becomes hard to walk. So it's a bit difficult to take that out of the performance of the shoe. Yeah. So what happens when you, why wouldn't you put a tread, or why would you put a tread, right? That was your question? Well, here's what happens when you add a bit of snow. So in this case, we're not actually walking directly. You'll see we created a snow walkway where we had the subject walking up and down. But that's actually not so bad. The worst case we find is when you have a little tiny bit of snow. So what actually happened was he walked up and down here a few times, slipped a little bit, and a bit of this snow ran over here. And so we have this dusting of snow now on the surface of the ice, right? And now you'll see at 10 degrees, this is the good shoe, right? This is boot 2, no longer able to go up 10 degrees. 8 degrees, no longer able to do that either. Right? So that little tiny bit of snow takes it from somewhere between 15 and 20 degrees, and suddenly he can barely go up a 6-degree incline, right? So what does that mean? Does adding a tread help? Maybe. Maybe adding a tread will help. We don't know yet, so that's something we'll do. Adding spikes could help, right? That's something we'll test out. But this is the type of testing that we're trying to do to figure out, that's now the worst case scenario, right? If even though you can climb this 20-degree wet icy slope, if there's just for some reason a dusting of snow, all of a sudden you'd slip and fall, right? So we have to be careful we don't give you really good traction in one case when there's this, other case where you could suddenly slip. So that's what we're working on now. So yeah, so this is boot 2 and that's boot 1. So this looks great, doesn't it? And this is actually, it's called a bear paw or bear foot, or because it kind of looks like the pads of a bear. I don't know, something like that. But yeah, it doesn't work terribly well. What about these things? I was talking about spikes. How do these things work? Would they help you on ice? Would they help you on snow-covered, a little bit of snow on ice? The little bit of testing we've done on these, we know there's a risk with the ones in the top right corner. And the risk is if you are outside, it works fine. But as soon as you step inside on a hard tile surface, those metal surfaces don't give you any traction, and so if they're wet and if you have a wet spot, it's quite dangerous. So again, something where it might work in one scenario but could increase your risk of falling in the way it's used. The other issue that we talk about slipping and falling is just on level ground on sidewalks. And we have a hypothesis that it's not the biggest cracks or these sort of bumps that you see. It's actually the smaller ones that might be causing us to trip and fall. These ones we see, right? We can see them from far away, and unconsciously, subconsciously, you step over them. It's the ones that you maybe can't see that are just a slight, even 1 millimeter or 2 millimeters of change in height that could be the ones that are causing us to fall. So we're studying that as well. So we actually have a little laser rig that we're putting outside on the sidewalk in front of our lab, and we film people walking by, and there's these 5 laser dots that project onto the person, and from that we can measure their minimum foot clearance as they walk past us. So we do this, and we don't have an answer yet, but we'll be able to do this over bumps of different heights, right? So we're going to find places where there are little bumps and big bumps and see where people are at risk of tripping up. That's another area that we think we're worried about. Stairs. Does anyone worry about stairs? Do you have trouble with stairs? Yeah? That's an area that we've heard is, as we get older, people start to move out of 2-story houses. They like moving to bungalows because getting up and down stairs can be hard. It's also dangerous. The number of, I think they say the stairs are the most common cause of falls, and the most serious falls are caused on stairs. So we have, another one of these simulators is called Stair Lab, and we can actually put a staircase inside it, and we can have people walking up and down stairs. And we can suddenly shake the whole platform, causing someone to fall, to see what sort of risk did those stairs put on that person, how close are they to losing their balance in any given case, just by giving them a little jolt. And then we can study if you had a handrail in the right spot, at the right size and the right height, can you prevent the fall by grabbing onto the handrail? How should handrails be designed so that they work, so that they can do that? This is a study, and so this is getting at the risk of falls on stairs. This is a study done in Britain where they basically sent out a survey to a whole bunch of homes and asked them to go and measure the height of the stairs and the length of the stairs. So it's called in Britain they call this the rise and this the going. So and they got back all this data, and they asked a simple question. They said, has anyone fallen on those stairs? Okay, and here the little black triangles are where there was a fall, and the squares, the white squares, are where there wasn't a fall. So if you graph that data by the length of the going, or how wide the stairs are, you'll see that there's a huge increase. As the stairs get shorter, there's an increase in the number of staircases with a fall, as you might expect, right? If you have really narrow stairs, you're at much higher risk of falling. But what's surprising maybe is how much more likely it is to fall on a stair that's a bit narrower. So these are in millimeters. So this is about like 8 inches, and on this end, this is about 11 inches. So if you have an 8-inch wide stair compared to an 11-inch wide stair, you're at a 6 times higher chance of falling down those stairs, which is pretty shocking, isn't it? Do you know what our building code allows for right now? What's the minimum width you're allowed to build a stair to? It's 8 inches. So we're in a battle right now trying to fight to get stairs that have to be at least 11. We think we might get 10. That's where it's an enormous battle. The builders don't like this because, of course, the staircase all of a sudden takes up more space in the house, and so that costs floor space and increases, they think, increases costs of the home. And so they fight tooth and nail to prevent any changes like this from happening.
Are you speaking about the part of the stair where the foot goes down?
That's right, the tread. The tread, yeah, the width of the tread, yeah. So it's the length. So if I'm stepping with my foot, it's how much space does my foot have to land on, right? What is that distance? So right now we allow that to be as little as 8 inches. And it should be 11, we believe.
Because so many feet would be low.
You can have different size feet, yeah, exactly. The risk is when you're going down, the most serious falls happen when you're going down the stairs, and if you overstep, it makes it much more likely that your foot can slip off the nosing of the stair as you step down. Yeah. Yes, oh yeah.
I live in a house that was built 25 years ago.
Yes.
And at that time, what was really popular with the home builders were these spiral staircases.
Yeah.
And
So
that's going to be a problem for me.
they're incredibly dangerous. Yeah, because we haven't even started to study special stairs like that. There's people believe that spiral staircases, open risers. So if you have nothing to stop your foot from. It's not that your foot's going to go through there. It's just that it's a visual distraction as you're climbing stairs. You can see through the stair. We don't quite understand why, but yeah, definitely there are more recorded falls on spiral staircases. They call them winders, and these open risers. The other thing that there's a lot of falls with, and I recommend people check for this, is what they call top-of-flight defect. So if you look down your stairs and you see how all of these ones sort of line up, this one is back a little bit, that means that there's something going on with the height or the width of that top step, right? It means that usually what it means is is there a marker that I can draw on that with by chance? Let's see. I can wave my hands around if needed. Oh, there might be.
No,
In this thing?
Inside it?
Yep. Let's just have a look. Let's see. Oh yeah, look at that. Okay, let's see. So, this top-of-flight defect thing, I'll bring this out front. So this again is something we don't understand. We're not sure if this is causing a problem or not, but we suspect it is because the people that study injuries that happen, so they go to court when someone dies from a stair fall and they report and they say, we investigated these stairs, it doesn't look like anything's wrong, or there is something wrong, the builders did something wrong with it, so who's at fault? So these people are telling us they're seeing more and more stairs like this and serious injuries happening on stairs like this. So what's happening is at the top of this stair, they're missing a nosing. So normally the tread has this overhang, right? This distance here. And the next stair will have another nosing like this, right? So what's happened is these stairs get built off-site and nailed in at the house, and the builder forgets to put that nosing on the top landing. So with that missing, what that means is that this distance is not the same as this distance, right? So when you're coming down the stairs, you see a bigger step as you step down, so you expect the next step to be the same, right? So you step down on here and your foot, ends up here somewhere. And then you step down on the next one and it ends up the same distance away from here, but ends up hanging off of this more. And so then there's a higher chance of getting a slip if you're missing this thing up here. Does that make sense? Yeah. So that's what we think. Anyways, that's the theory. We have to test that to see. Yeah. Question?
Also look at the visual cue in terms of sometimes looking down the stairs.
Yes.
The treads they all look the same.
Yes.
So you can't distinguish necessarily
Where the edge is. Yeah, so having a bright strip of material there is good. Yeah, being able to tell where the edge of the stairs is very important, definitely.
Well, it's not code or
There, in public buildings, it is. In homes, I'm not sure that it is. You're right. Yeah, that is another important thing to think about. Yeah. How are we doing for time? 1:30. Okay, good. So we showed you that. So what we do is we actually build different wooden staircases. Aside from having the stair lab thing, we have just these big wooden staircases where we can slide the stairs and make different length treads, essentially, and have people walking up and down them. And then we have 3 different heights of stairs to see. But we're still trying to understand, really, what is the risk of these different heights and different widths. Where is the break point? Is 11? We're not even sure that the 11, I'm talking about 11 inches as being the ideal. We don't know that that's true yet. It's just better than everything else so far. It could be that 12 inches is even better, right? So we're still trying to work that all out. The important thing, I think, for this work is, getting people to understand that there is a value to a longer staircase because if it means we can live in that home longer. We're going to talk later about the need to be able to stay in your own home as long as possible, how people are happier and healthier, live longer if they can do that. And stairs are an important piece of that puzzle, so we want to be able to develop stairs and build stairs that allow people to do that. And so maybe we want to be able to pay a premium for good stairs in our homes so that we can live in them longer. Falls so moving back to falls again now, when you're being taken care of, so if you're a client or a patient in a hospital, falls are always a big deal in that environment as well. So this is some data from the Ministry of Health. I just want you to look at the top line there. So percent of long-term care residents who had a fall in the last 30 days, 14% of those residents in a long-term care facility had a fall. In home care clients, 30% had a fall in the last 90 days. I know it's not measuring really the same thing, but the point is that in hospitals or when people are taking care of you, you're weak, you're maybe ill, or you're recuperating from something, or maybe you had a hip replacement and you're healing up after that. It's really important to try to prevent falls during that time when you're being taken care of. And there's a lot of falls happening right now. So we're trying to figure out how to make those numbers go down. And we're interested again in the home and in the clinical environment. So we have 2 other simulators. So I showed you Winter Lab and Stair Lab, right? Those are the 2 that get mounted on top of that moving platform. Those are downstairs in our basement. These 2 are upstairs on the 12th floor of our lab, and you can actually look down into them, so they don't have any roof. So from the 13th floor, you can look down into them and see what's happening. And it's for us to understand how people, in a home, how do we retrofit a standard home environment for someone who's living there with a disability, right? As we age, what are we going to need to do to that space to be able to make it more supportive for our needs? And in the care environment, so in a clinical environment, we have this basically a mock-up of a hospital room where we can study interactions between patients and caregivers and the problems that we face there as well. One of the simplest things that we can do to prevent falls in long-term care and in homes is give someone something to hang on to, right? Putting lots of things to grab onto is simple and inexpensive and really effective. If you have stuff that you can hang on to while you need to move around, you're going to prevent a lot of falls. So we've developed a very simple product that is a pole that you don't need a contractor to come and install. It holds itself in place between the ceiling and the floor, and it just sticks there, and you can put more than one of them. So beside, typically maybe getting out of bed, if you're someone that's just had a hip replacement or has trouble getting up and moving around, you want something in front of you that you can pull up on to get yourself out of bed. But then what do? Well, next maybe you need to get to the bathroom. So we've developed a system where you can clip horizontal bars in between these vertical ones. So you can create a set of handrails taking you maybe from the bedroom to the bathroom. Right? And so we've designed these, we've tried to just come up with a really simple, really cheap system that will let you be able to quickly put handrails up wherever you want, and try to get over some of the barriers that people have about changing their environments, right? If you talk about screwing handrails into walls, people don't want to do that. That hurts their property value. They, damaging the walls, and there's this barrier that people don't want to cross sometimes. So we think that this sort of solution, where you would go to IKEA or Home Depot and buy as many of these vertical pieces as you need and as many of the horizontal pieces as you need and put them in place, is a good solution that we're hoping will take off. So this is actually now just about to be launched. The commercial partner we're working with is just about to commercialize. We're calling it the Home Care Mobility Kit, I think. So that should be coming out soon. So the obvious problem you can have with this thing is that you'll block access to a closet or something. So really all of these horizontal pieces have a disconnection. So they're all sort of like a gate. So you can unlatch, you pull this big handle, and it unlatches the gate for you so you can get through them as well when you need to.
Is that plastic?
It's plastic, yeah. Yeah, so there's someone showing you how you unlatch it, and it sort of lifts out of the way, and you can get through there. We have the same sort of thing in the clinical environment. So the people that we work with, Jeff Fernie, who is the Institute Director at our lab, he's had a lot of experience with patients that go into, they have some sort of an accident or, maybe a stroke, and they go into the hospital, and they always end up coming out much worse than when they went in. And it's not because of their condition, it's because they were laid up in bed for so long without moving around, and they were dependent on a nurse to come by to help them out of bed. So they were only able to do that, they weren't able to do that very often. So they it's called deconditioning, right? You use it or you lose it, right? So giving someone a simple bar beside the bed allows them a lot of independence and the ability to get up and go to the bathroom themselves maybe, or get to their walker, or get into their wheelchair, and it maintains a lot of that strength and muscle tone that we don't want to lose. So in hospitals, the issue is that you can't rely on a ceiling because it could be a drop ceiling, so we need something that bolts to the wall. So we came up with a variation of the kit poles that I showed you earlier with a bracket that bolts to the wall, but it's the same idea really. And this just shows how someone might get up and use their walker. So Care Lab, another big issue that we worry about is infection control. So right now, 1 out of 10 people that goes into the hospital in Ontario comes out with something they didn't go in with, right? So you pick up a bug in the hospital that someone else had. And likely that's because a nurse or a doctor didn't wash their hands when they were supposed to. And so there's a spread of infection. So the province and the Ministry of Health has been very interested in finding, tracking and motivating people to wash their hands. And so there's an auditing process that happens now in hospitals where auditors go and stand in the hallway and watch as nurses and doctors perform their work and make note of how often they forget to wash their hands. These are the results from 2009, and so you can see, did they wash their hands before seeing the patient and after? You're supposed to wash your hands before and after. One hospital here reported, so each of these dots represents one hospital. One hospital reported 100% compliance. They washed their hands before and after seeing every patient. Many more hospitals did really well after seeing the patient, but didn't do so well before, right? On this scale, they were down here. So you want to be up here. The problem is, of course, people act differently when someone's watching. You know, if someone stood next to you and watched you do a job, of course you're going to do it a bit better than you normally do. So we don't really have a lot of faith in these numbers. But even so, it's a little shocking to see the numbers where they are, right? So to see in some cases, very low rates of hand washing. So we've been working on a system that prompts people to wash their hands when it's needed. So really the system is based on a little badge, and it might be a piece of electronics that's built into the name tag that, you know, a nurse or doctor wears, that has a little electronic eye in it, and that eye looks up at the ceiling and it sees a bar. So in this case I've covered up the bar with these arrows, but there's a little bar up here with LEDs in it that shines down light, and when you walk into that room, it detects that you're going into a patient zone, and if you haven't just washed your hands, it prompts you to wash your hands. So there's a similar thing here that talks to your badge as well, and it records when you activate this pump. You walk up to the alcohol gel dispenser and you activate it and wash your hands. It recognizes that you've done that and logs it. So it not only prompts, it also tracks much more accurately than someone standing with a clipboard. So we think systems like this are the future for this type of work, and making sure that people don't die from this sort of thing. Right now, 1,000 people every year in Canada die because of what they call a nosocomial infection, something you picked up in the hospital.
That works very well for the staff, that you have such control.
Yes.
But then there are visitors, and
Yes.
there are people who bring their children.
Yes.
I was in the hospital the other day,
Yes.
and someone came in with a child that was obviously quite
Sick.
ill.
Yes, yes.
It was, you know, snotty.
Yes.
And I thought, what are you doing to them?
Yeah.
And, you know, like, they think that's great that they go and see grandma or whatever.
Yeah.
Well, grandma could die because of that infection. I mean, there has to be
Yeah.
a lot of public education.
That's a good point.
I think, you know, I think most doctors and nurses, even if they don't do it, they get it because they see the effect of it all
That's right.
the time.
That's right.
But every day, you know, you just
That's right.
drives you crazy.
That's right. Yeah. And pardon me, drives you crazy. Yeah. That's an important point. Just to touch on that you. Pardon me.
Made it here, I think.
Oh yes, yes.
How about hospital personnel who goes to Tim Horton with their scrubs and all their uniforms? Would you study about it?
That's a good question. I mean, yeah, I think obviously anyone who's serving food should be clean. Hospitals are a particularly, it's a different environment where you have people that are, have problems with their immune system because they're sick. So they're particularly susceptible to other bugs at that time. Definitely, I mean, I'm sure at Tim Hortons they should be cleaner and wash their hands as often.
The hospital personnel were the one using their uniforms inside.
Oh, I'm sorry, I misunderstood. The hospital worker was wearing their scrubs in the Tim Hortons? Yes. Yeah. No, that is a bad. Yeah, that's right. I mean, I guess what you hope is that they were on their way to work rather than going home. But you don't. Obviously, there's some people I'm sure that wear their uniforms home. But yes, you're right. That's terrible. They should be changing out of their. You see people also in the elevators wearing gloves and pressing buttons. It's like, at the hospital all the time. It's. Yeah, no, definitely. There needs to be more public education. But around the issue of, nurses and doctors understanding the problem, you're very right. I think no nurse or doctor ever, if you asked anyone specifically, they would say, oh yeah, I wash my hands all the time, but I see my coworkers missing, they forget all the time too. It's the type of thing where you don't notice yourself forgetting because it is a hectic environment. There is... if you add up the number of times you're supposed to wash your hands over the course of an 8-hour shift, it adds up to 100 opportunities, they call them. And so if it takes you 30 seconds to go to the pump and wash your hands or something, it's like, almost an hour that you're spending washing your hands. So it's easy to let that, to miss those. So that's the idea behind this badge, is that it prompts you. It's not supposed to, make you feel, it's not like your boss is going to fire you if you miss one, but it's, you probably are more interested in the data than your supervisor is, I hope, right? That's the goal.
About inventing something where they just go like this.
Yeah.
They walk in. I mean, like you have in science fiction, it goes zap.
And it cleans you off.
Like that.
Yeah.
Healthcare system can't afford it.
We'll see about that. Yeah, maybe in the future. Maybe. Yeah. The other important thing I'll just tell you about this little thing. You see the green light on there? That's very important. We think that is what's going to make this work, because if you walked into the room without washing your hands, the green light is off, and when you wash your hands, it goes on. So now your coworkers and the patient can see whether you've done things the right way, and they can ask you, it says, shouldn't your green light be on before you whatever? And then the doctor can say, oh, these things never work, and then they go over it and activate it, right? So it's not about making people feel bad about it, but it's making everything more, the information more accessible to everyone. This is what the new version is going to look like. It'll basically be a smoke detector stuck above the door that looks down at those badges. One of the other big problems that we look at in the clinical environment is back injuries in caregivers. So lifting and moving people is a big problem. Nurses hurt their backs more than any other workers. Minors, so it's like 3 times the rates of back injuries compared to minors, which blows my mind. But it kind of makes sense if you start thinking about it. People, you can't change their size and their shape, and you have to lift them gently. Whereas, in mining and construction, you can limit the size of the thing that you're lifting, the box or the piece of tool or whatever it is. So it's a big problem, and in particular home care workers get hurt more than anyone else. So in acute care, long-term care, it's these home care workers that are at the highest risk of getting hurt. And that's data from a paid worker, right? People don't keep data on informal caregivers, but the reality is most caregiving is done informally, right? It's an older couple living at home together, the wife providing care for the husband. We have to make sure that she doesn't hurt herself taking care of her husband, because if she did, both of them would end up in a nursing home. And that's one of our targets, is to try to keep people out of nursing homes as long as possible. Again, people are happier and healthier and live longer. There's now lots of studies that show people live longer if you live at home. So that's the target. How do we support that? And keeping in mind now it's 2 people with disabilities taking care of each other, really, right? So it's designing all of our systems to account for that. So the person could obviously be in a wheelchair. So, back injuries, it's mainly the low back. The rates are astounding to me. Every time I look at these things, this is what I did my PhD work in, a nurse has over a lifetime an 83% chance of having a back injury. It's a terrible risk that they take on right now, compared to the average population where it's much lower rates. And as I said, it is due to patient lifting. Although we know now that lifting manually like this is definitely not or shouldn't be allowed. So all lifting, what we call lifting now should be done using mechanical lift devices. So now if you go into a hospital or nursing home, you'll see either on a track on the ceiling, a lift that sits there, or it's a wheeled thing. I'll show you a picture here. Maybe I don't have a picture of that, sorry. Anyways, the overhead lifts or floor lifts, there's 2 different kinds that you can basically put something under a person and allow them to be lifted up so that the nurse doesn't have to do the manual lifting part of it. But the challenge is that we still see lots of injuries in nurses, and these lifts have been around for 20, 30 years now. So we're trying to understand what it is about the remaining tasks, or even the use of those lifts now, we think, could be part of the problems, right? So and one of the activities that we're worried about is the activity of getting a sling under the patient before you can lift them, which is common. Anyone who's done this knows that it's a really tricky job. So the thing that the patient here, so this is an overhead lift with a patient hanging in it, and getting that piece of cloth that she's hanging in under her before you can hook it up to the lift is the challenge. So we've developed some techniques to be able to measure this stuff in the field. So we go into nursing, in the clinical environment and measure stuff, and then we can track the movements and record the loads on the spine and figure out what activities are safe and which ones aren't. Like I said, this activity of getting that sling under the person is one of the ones we've studied, and whether it's one person doing it or two, and what we find is it's actually quite dangerous no matter how you do it. And that's with a 200-pound patient. So think about now if you're talking about a 400, 500-pound patient that we're seeing more and more nowadays. That's why we think we're seeing rates of back injuries in nurses either staying constant or going up, depending on what jurisdiction you look at a time when all other workplaces, the rates have been going down consistently over the last 10, 15 years. Nurses, the rates are going up. We think it's because, well, nurses themselves are heavier, so you're carrying more weight on your upper body that you're now supporting with your back, as well as the patients that are getting bigger. So how do we solve that problem? Well, we have a product that we're developing. It's called Sling Serter. Let's see if this one plays. There we go. So this is, it's a little pneumatic device, which means it uses air pressure to inflate a strap under someone. So now you don't need to do anything. This strap will just shoot under the person using this compressed air canister that's attached to the trigger thing there. And once you take off the little plastic bit, you reach in and grab a loop on the other side. So now you've got a strap, basically a piece of seatbelt material that's under the person, and you can put 4 or 5 of those under the person, attach them to a lift now, and lift them up without any work at all. It has the neat feature that you won't hurt anyone's skin when it's going in, as well as when it's coming out. It turns back inside out on itself when it's ready to come out. So this is just going to demonstrate the whole process here. So we're really excited about this. Any nurses we've shown this to are really excited about this. We think this is going to change the way caregiving is done, actually. We're working on a home version as well. So for people, like that, the older spouse taking care of her husband, she has to be able to do this, right? So there's going to be a simple way to make that happen as well. So the goal is to be able to lift them up just a little bit. You don't need to get them too high, because most of the activities you're worried about getting a bedpan in, changing the bed sheets, repositioning people in the bed, you can do just by lifting a little bit. And if you did want to lift them right out of the bed into a wheelchair, let's say, you can put the normal sling under and use that to lift them out the rest of the way.
What if you need just to, when someone is an orthopedic patient?
To turn them?
Just turn them.
Yeah.
Away. 'Cause I have a sister who's a nurse and back problems.
Back problems. Yeah. So.
And I don't think that would work, because you just need to turn them like that.
Yeah. There's ways of using. I've seen ways of using slings to turn people. So you hook up. So once you got the sling under, you can hook up the 3 straps on one side to the lift, and use that to get them to roll over. Right. That's one way of doing it. Yeah.
What's the name of the system again?
That's called Sling Serter. Yeah. And this is, what it looks like to have someone up. So we've tested this now with about 60 nurses and OTs and PTs, and they gave us their feedback and what needed to change. The next thing is to test it with the heaviest patients to see how many straps you need, where do you position them so that you're not cutting into their flesh, that sort of thing. So that's our next big target. So far, we've tried it with 3 of us stacked on top of each other. So we figure we had probably about 500 pounds that it shot under so far. Okay, so quickly I'll go, so about 5 minutes. I want to leave lots of time for questions if there's other questions, but we can go through a few more things here. Working on, so living at home, what we're talking about, we're trying to always find new ways of keeping track of what's happening in case if there's an emergency. So if you've fallen, there's the buttons that people have, they wear around their neck. And unfortunately, they either don't actually wear them, or they don't press them when they've fallen because they don't think it's serious enough, or they're unconscious and they can't press them. So we're developing a system that's an automated thing where it really just monitors the room. It's a thing that looks like a smoke detector stuck to the ceiling that has a camera in it, but no one sees that image. Only the computer is processing that image. And if it sees that something has happened, someone's fallen, it starts talking to you. So it has artificial intelligence built into it, and it says, "Are you okay?" You can say, "Yes, I'm fine, I'm doing exercises," and it'll leave you alone. But if you say, "Yes, I need help," or if you say, "No, I'm not okay, I need help," it will ask you who you want it to call for you. So it can call your neighbor or your family member, or it can call 911 by default if you want. You program that all in ahead of time. And the idea is that it would open up a conference call basically between the people that are there. And and it can together as a group you can then decide how you want to approach the problem. So now think that's the product that's almost on the market now. The next generation will use that same camera to track how much someone's eating, how much they're drinking, to make sure that they've taken their medication, and try to make other things in the idea is I think the guy that works on this, he calls them bricks. So he intelligent bricks in the environment. So there's these things that are there, and they go about you go about your business, and you don't really even know that they're there and what they're doing. You don't need to worry about it. But if there's something that goes wrong, it notifies the person that there's something wrong. So that could be monitoring things like blood pressure by simply, if you sit on your toilet, they're working on something that can measure your blood pressure and heart rate just from you sitting on a pad. So they can, without you even having to put a cuff on, you can measure blood pressure. So you can tell, you can start tracking these things and looking for trends to see if something bad's happening. What else can I tell you about their team? Oh, the other thing you could imagine this thing turning into is like the little robot vacuum cleaners. They're going to try putting one of these attached to one of those. So it's like this thing that might follow you around and prompt you for, is it time to take your medication? Is it, it can try to. They're actually trying to see if the little camera on this little robot could be able to tell whether you're eating Cheetos or carrots, right? Like whether your nutritional, what is your nutritional input coming to? So that in the future, I think that's still a ways out, but it's phenomenal what we might have the ability to do.
And if you're eating Cheetos, it comes along and it nits at your
and it gets mad at you. That's right. That's right. Okay, I'm going to zip through. I'll just quickly mention a couple of other things, and we can ask lots of. Do people have questions now that they want to ask? We can start going. Yes.
What if there's no response? That ceiling monitor. What if there's nothing? Does it?
Oh, then it has. I think it calls 911 if it doesn't hear anything. Yeah, I think it assumes the worst. Yeah. Sleep apnea. Does anyone here know someone or someone have sleep apnea? So this is what you would. Maybe we can talk about this for a second. This is what you would. Have you been to a sleep lab?
Yes.
And you look like this?
No.
Did they put what? Did they put stuff?
It was something like that. They put a lot of wires here, there, everywhere.
Yeah. So were you able to sleep when you had your test done?
I was.
You were able to sleep. That's good. A lot of people complain that they aren't actually able to sleep very well. It's a strange environment. You have all these wires stuck to you. So we're working on a home-based version of this test. So the challenge is that people right now. So 7% of the population has sleep apnea, but only 10% of them know they have it, because it's so hard to get tested and people don't want to go to a sleep lab to do it. But this is a version of the same testing system. Well, it's not the same testing system. It's a different testing system, but you wear it at home. It listens to your breath sounds, and in the morning you send a little memory card in the mail back to the lab, and they can tell you whether you have sleep apnea or not, as accurately as the sleep lab can. So we think this is going to be a huge impact on people with sleep apnea. It's car accidents. A lot of times those rollovers you hear about on the highway at 3 o'clock in the morning, probably truck drivers that have sleep apnea that aren't rested enough. Yeah. So we're very excited about this one coming out. It'll be something that we imagine your doctor will prescribe. So we imagine this thing will cost like $40 or $50 that you'll go to a drugstore and your drug plan might even pay for it, and you go home and you test it, and you can test yourself multiple times, right? It's just this device that you can then use whenever you need to, and sleep apnea is one of is the one disability that I know of that is curable in a sense. Do you use a CPAP machine now, or do you?
But I don't.
You don't like it. So we have to develop a better way of doing CPAP, because does it dry out your eyes? Is that why you don't like it, or?
You
You just don't like it.
don't like
Fair enough.
doing that because my bedroom's usually so messy that I can't use it.
Fair enough. Okay. Anyways, it is something that people talk about, depending on how bad your sleep apnea is. I've heard people talk about it changing their lives once they got a CPAP machine. People go through their lives kind of drowsy and just not performing the way they want to. Yeah. So it is something, if we could just diagnose these things, we could help people a lot, we think.
Can you share these home kids?
Pardon me?
I mean, these kits, if they cost $40 to $50, and a whole bunch of people want them.
Could you share them? Yeah, I'm sure you could. I mean, it's like any, the infection control bit is the critical thing. You know, you don't want to share and get bugs from people to other people. So this wouldn't be designed to be that. It would be a plastic thing that probably would be designed to be disposable, rather than making this a $200 device. Keeping it a $50 device would be the goal, I think. But it's you know, within your family, I'm sure you could share it, but you probably wouldn't want to share it with your neighbors. You know, that sort of, yeah. One last thing I can talk about is, you know, the home care we talked about. It's always the caring for someone in the home. It's the bathroom that's the big challenge, right? Bathing, toileting. So we do a lot of work around how to prevent, or we're just, right now, we're even just trying to study how it happens. I mean, obviously we're trying to prevent injuries. We haven't gotten there yet. We're just trying to figure out how we can make the job easier for these PSWs that go into people's homes and bathe and toilet people. It is a horrendous job right now. There's no space. If you know, in a typical bathroom, you've got the vanity right up against the toilet, right up against the bathtub. You know, PSWs are hunched over, twisted and weird angles, getting people on and off of toilets, into bathtubs. It is really quite a dangerous job. We're working on, okay, sorry, one thing, so just to back up a step, you know, if you're someone who uses a walker and has trouble moving around, maybe you would find a raised toilet seat to be useful. We developed a while ago, you know, there's these two options for having raised toilet seats. There's about 100 million of the one on the right, where you sit something on top of the toilet, but it gets messy really quickly. The one we developed goes under the toilet, so you bolt the toilet on top of this thing called Toilevator. And it does the same thing, keeps it clean, it looks more normal. We're using that now. We're going to build a new attachment to that to help move the toilet in the bathroom. So it's this, we're calling it Toy Locator, and it's going to be basically a toilet lifter base, but it has a pipe that comes out and joins where the old toilet used to be. So we actually think this will help this situation quite a bit, not only for, you know, for the PSW. I think it might make it easier for someone using a walker who might not have enough room to get the walker out in front. Here, we'll be able to now back into the toilet much easier in this scenario. So just allowing for a foot or two of movement one way or the other away from where the toilet was originally designed, for, you know, $200 product, we think could be a big benefit. Yeah. For toilets?
Well,
for spaces, or?
Particularly bathrooms, kitchens. I'm thinking of these new condominiums that are so tiny.
Yeah.
I really wonder how.
I'm sure there are requirements, but I've seen some really small bathrooms and kitchens, and I don't know whether, yeah, is it that they don't follow them? I'm not sure. I'm not sure what the requirements are and how reasonable they are versus, you know, could someone, I mean, are those requirements designed to allow someone with a walker to access the toilet? Probably not. That's probably the limitation, right? Yeah.
Like, would it be worthwhile, though, to work with a developer? I mean, one of the issues that I see is actually trying to stay in a home.
Mm-hmm.
And it's not that it's, you know, that a condominium or an apartment can't be your home, it can be. And instead, working with them on purpose-built senior residences type things.
Sure.
That aren't horribly, you know, like aren't a nursing home, aren't like a sort of a step above a retirement.
A middle ground.
So it's still your own space.
Definitely.
But that you are able to influence. You don't even have to worry about a building code. You just work with the developer
To make that work.
To make that possible. Because my only experience with the building codes with this is where your toilet and bathtub have to be in relation to your main sewage stream. Like those are usually the kinds of things they do, as opposed to dictating the size of the bathroom.
Right.
Because that's pretty impossible to do because people renovate all the time.
Yeah.
You know.
Yeah, yeah.
So I mean,
That's
that to me would be something that, especially when you look at downtown Toronto, and I know you're at where you are, physically your office is. The streets get bad, but they're not as bad as they are in some of the outlying
Sure.
areas, for example.
Sure.
Where they get a lot more snow.
That's right, that's right.
So, you know, and you have a better chance, by the way, of getting your sidewalks cleared
Yes.
at Yonge and Dundas
Yes.
than you do at Burnham Thorpe and whatever.
Fair enough. Yeah, yeah.
So,
Yeah.
I mean, to me, there are ways of engineering your own environment that have to be looked at and working with the people
Yeah.
who can help you engineer your environment.
Definitely.
Stay in at home, something
Yeah.
that is yours, not necessarily the two-bedroom bungalow or the two-story,
Yep.
three-bedroom.
Yeah, I agree with you. I think definitely there's those types of solutions in Whitby and in Waterloo. The Schlegel Group has been working on sort of this idea similar to that. They have sort of a continuum of nursing home tower on one side, you know, seniors living on the other side with like a mall in between.
You have to live in Whitby.
Pardon me?
You have to live in Whitby.
You'd have to live in Whitby there, yeah. Yeah. I mean, there's I think 5 or 6 of their homes around in different places. I forget exactly where, but yeah. I mean, there are people thinking like that. That's a good thought. One of the things that I always think about is, you know, my parents are getting older, and if I want to move, they live up in Sudbury, and you know, I think life would be easier for them in a place like Toronto where they have access to public transit as they start to not be able to drive maybe. But they have all these connections, right? Their neighbors, they take care of each other. And, you know, I think that's a powerful connection that you don't necessarily want to sever if you can.
Yeah, there is social media, there is
Yeah.
Skype, there's all sorts of, there
Yeah.
are you know,
Certainly.
technologies that will allow you to do that. You're right, you can't go to the concert with your friends.
Yeah,
but
yeah.
There are ways of still keeping in touch.
Certainly. It's not so much the keeping in touch, but it's the when they're feeling sick, can someone come to you and take you to the doctor, right? I think that's, I really, you know, I value my parents' neighbors. If I don't get an answer for a couple of days on their phone or whatever, if they've forgotten to call me back, I'll call them and I'll know right away whether everything's okay or not, right? Because I know they're looking in on them. And it's...
I spoke to the city planner one day,
Yeah.
and I said, they're building these 50-story buildings. Why can't they take 10 of those floors for the older people?
Yes.
Make that a senior's home. You have all the facilities, including the pool and everything,
Yes.
that you don't get if you move to a retirement home.
Yeah, yeah.
And then you
There's-
also have,
I think the mixed-
have the young people within the building.
I think the mixed living is the solution,
It would
yeah.
be like living in a village,
Yeah,
kind of,
yeah.
because you've got everybody all ages.
Yep, I think that is, I think that's the healthiest living scenarios are always like that, where you mix.
You talk to somebody about
Well, I don't know if I have any influence in that area.
planner, and she said, "Oh, that's a great idea."
Yeah. Oh, the Jennifer Keysmat, is that? Yeah, she seems like she's a sharp. She's sharp,
I
yeah.
hope that she was going to pay attention.
Yeah, good. A few more pictures, and I mean, keep asking questions if you have questions, and I have a few other pictures to show you here. These are the simulators that we've been talking about. So Winter Lab, Stair Lab. We have another one called Street Lab, where it's a projection of a streetscape, and we study things like people who have had a head injury or a stroke. How do they deal with the complex noises and you know, stuff coming at them at a busy intersection? Can they navigate? Can they safely cross a street when an ambulance is coming by? Right? Can they make sense of all that stuff? So those are the 3 labs, and each of them can get lifted up. There's a crane that picks up these pods and places them on top of the motion platform. So all 3 of these can be swapped on and off over there. And we're building, we already talked about Care Lab and Home Lab, and we're building one more, and it's going to be called Driver Lab. And it'll be used in the same sort of visual surround sort of thing. But it's going to be a driving simulator that has much, it's very different than anything that most people have seen. The goal is to be able to create real rain that you have to turn the wipers on to be able to wipe away. And maybe the wipers don't work perfectly. Maybe they're like a few months old and they're starting to crack. And they're, at night, there'll be headlights, glare from headlights coming at you. So, you know, what are really the most most challenging things that when you're driving that you have to deal with. It's stuff like that. So our simulator is going to try to recreate some of those things as realistically as possible. Maybe even turn the temperature down. We'll make it cold in the car when you first get in, so you'll want to wear your mitts and your hat. And how do you drive with all that, with your bulky jacket on and everything? And the goal is really to make a graduated delicensing system to see if that's something that could work, rather than saying your doctor at some point coming to you and saying you're no longer able to drive. We think it's really important that, you know, the ability to get to the grocery store and to the doctor's office during daylight hours, maybe during not taking highways, but in, you know, some restricted ability to drive becomes more important as we get older. And so we think that's something we might be able to do. So we're testing what are the critical features that we need to incorporate in a simulator like this, so that we could deploy them. You know, one in North Bay, one in Sudbury, and the licensing people can use those to gauge what someone's capabilities are. So that's an upcoming project as well. So I'll just end off by saying, you know, half of us in our lives will have a disability ourselves. Right now, about a quarter of families provide care for someone with a disability. So that, if you put those two things together, it means that all of us will either have a disability ourselves or take care of someone with a disability. So it's really, you know, all of us have to deal with these problems at some point. 1 in 5 of us, if you're really lucky, you'll have both. You'll be taking care of someone while you have a disability, as I think we talked about that a little bit earlier. So that's, you know, that's the goal of our work, to try to make that, you know, when we do face these problems with disability in our lives, that we have some tools that work a little better than what exists now. So I should just say that our work, you know, the work I'm presenting here is from a vast team of people, and I haven't named them all in person, but there's a big team behind us doing this work. Jeff Fernie in the front here, who was also the subject that was walking back and forth in those slip videos, he's the Institute Director at Toronto Rehab, and he's really the brainchild behind all these simulators and all this work, and there's a bunch of us that love working for him. So thanks very much.
Thank you so much. That was really, really something.
Good.